Measuring flux density. Flux density can be measured using two different methods, depending on whether the field is steady or changing. A steady field can be measured using a Hall probe, and a changing field can be measured using a search coil. First we'll look at the Hall probe, measuring this region of uniform magnetic field going into the screen. The main part of a Hall probe is a slice of semiconductor material. We pass an electrical current through this, which in this case will involve electrons moving from right to left, shown here with the speed v. The electron is a charged particle moving through a magnetic field, and so it will experience a force in this direction. This will lead to a build-up of negative charge on this top surface and a deficit of negative charge, therefore a positive charge, on the bottom surface. Placing a voltmeter across these surfaces allows us to measure the potential difference between the top and the bottom of the semiconductor material, and this potential difference will be in direct proportion to the strength of the magnetic field. If we have a changing magnetic field, as here, going into the screen, out of the screen, into the screen, out of the screen, and so on, we can use a search coil. This consists of a coil of, say, 5,000 turns on the end of an arm like this. We connect the ends of the coil to an oscilloscope. As the changing magnetic flux through the coil induces an EMF, this can then be measured using the oscilloscope. It's important that the Hall probe and the search coil are perpendicular to the magnetic field they're measuring, and we tend to get two designs. Arms like this, with the Hall probe and the search coil on the ends like this, to measure a magnetic field in this direction, or a design like this, where the Hall probe and the search coil are mounted on this upturned section to measure a magnetic field in this direction.